how a random forest works. If you see the picture, we have random forest split into multiple decision trees, tree 1, tree 2, and likewise we have tree n, and different classes getting trained. First tree training on class A, second tree training on class B, and class likewise we're gonna have, right? Finally, the resultant would be the final class based on majority voting. So, well, um, we can contrast this approach as called as bootstrap aggregating. So in this approach, basically, random forest data is taken and each data set is split into multiple training data sets, and that way it's processed, and that's the reason it's called as bootstrap aggregation. Now the model is fit to these smaller data sets and predictions are aggregated, and several instances of the same data can be used repeatedly through the replacement sampling, right? So you can also replace the data in tree 1 and replace with data set 2 and then train the model, right, on that particular random forest decision tree. And the result is that the trees that are not only trained on different set of data but also different features used to make decisions. So now let's take a little bit different approach to understand how it's done. So now if you see this chart, so assuming let's say there are 1,000 data points, or let's say a million data point, you can split that million data points in 10 decision trees, so you are left with 100,000 data points, and each data point is unique from 1 to 100,000. Likewise, let's say there are 40 features, you can split them, so now you can have 4 features and each training set on each decision tree, and this could be varying. I'm not saying you have to take equal, but it's up to the random forest how it's going to prune the features and then be able to take into account what features to take in each decision node. Finally, the voting is done, aggregation is done. Finally, based on that voting, whichever class has the highest voting uh, classification, that classification would be our prediction class. Now, these are the steps for random forest algorithm to compute. First, step 1, select random samples from a given data or a training set. Step 2, this algorithm will construct a decision tree for every training data. So that means you're counting every training data, right? And that means they're all done parallelly. So there's no sequential processing in random forest. Finally, the voting will take place by averaging the decision tree. Step 4, finally select the most voted prediction result as a final prediction. So if you were trying to predict out of ABC class and B class is the highest majority voting class, then your prediction is class B. Now let's take the example difference uh, between the bagging and boosting. And the approach when we do bag and boosting, the combination of multiple models is called ensemble, and ensemble uses two methods, bag and boosting. Bagging is creating a different training subset, as we saw in random forest, from the sample training data. That means the data can also be replaced. It's called bagging, and the final output is based on the majority voting. The second class for ensemble is boosting, and where you combine the weak learners and the strong learners by creating sequential models such that the final model has the highest accuracy. So if you see between the left and right, so in bagging you're doing sequential processing, and you can also replace the data, and you have uh, created several cross folds of the data sets, and you're processing them sequentially. Finally, you're taking the vote. While in boosting, you're taking the features and you're training on the best features, and it's processing in a sequential manner so that the model predicts based on the highest accuracy. And that's the examples are AdaBoost and XGBoost. All right. So now that we have done that, let's go ahead and start building our first model. That would be linear regression, followed by we're going to do random forest, and then eventually we're going to compare both the models. So I hope you guys enjoying the lectures. Stay tuned for more lectures, and I'm going to see you in the next lecture. Thanks for joining.